Hi students, welcome to the session on equipotential surface. In this class we are going to learn about what is equipotential surface, right? So what are the properties of equipotential surface and what is, right? So properties of equipotential surface, right? As the name itself is telling, it is a combination of equal plus potential. What is the meaning? So equipotential surface is a surface in which all the points are at the same potential. A surface in which all the points are at the same potential is known as equipotential surface. Here you see we are having three equipotential surface, that is V1, V2 and V3. That means what? All the points in V1 are at the same potential. Similarly, all the points, let us assume these are all the points. Yeah, all the points are at the same potential. Here also all the points are at the same potential, right? So it is very important one. So electric field I have drawn perpendicular here, right? It is the electric field is perpendicular to the surface, right? So E is perpendicular to equipotential surface. Like that only we have to draw. Why electric field is perpendicular to the equipotential surface? That is very important. I will explain in this video, right? So first we know what is equipotential surface. Next, another thing we have to remember is for point charge, equipotential surface is concentric spherical shells. Very important point to be noted, right? Why for point charge equipotential surface is concentric spherical shells? We will see now. Before that, we have to remember or understand some points here, right? So here you see this is a point charge plus Q I have drawn here, right? So this point charge, right? These magenta lines are electric field lines. These blue lines are equipotential surface. Okay. So you see all the blue lines are concentric spherical shells. Yes or no? Right? This is electric field line. Both are perpendicular to each other. And moreover, you note that closer to the charge, potential is, we mentioned this point is having a potential of 70 volt. All the points lying in this circle, right? So all the points lie in this circle have potential of 70 volt. Similarly, right, all the points lie in the circle. You see, this is all the points in this circle have 30 volt, right? What is the reason? Okay, so we know that, that's what we are going to see now. We know that potential due to point charge is given by Q by 4 pi epsilon naught R. From this what we are understanding, V is inversely proportional to R. What is R? R is the distance between the charge and the potential point, right? So R is the distance between source charge and the point where potential has to be found, right? So here you see from here to here, from here to here, this is R, right? So what we are learning from here, if R increases, what happened to be decreases, because inversely proportional. That means when distance between the source charge and the potential point is increased, potential will be decreased. That's why you see this point, this circle, all the points in this circles are far away from the charge, so they have less potential, whereas these lines, these circles have the points which are closer to the charge, so they have higher potential, 70 volt. This point lies between those two, so the value lies between those two. Suppose if you want to find what is the potential here, this will be greater than 70 volt. Suppose if you want to find here all the points, they will be less than 30 volt, because all these points are all having 30 volt. We are increasing the distance further, so if you draw, so all the points in this area, right, are having the potential less than 30 volt. For example, let us assume this is a point charge Q. I want to find, this is a distance, let us assume 1 centimeter. I want to find a potential here, let us assume we got 2 volt, right? This is also 1 centimeter, so it will also give 2 volt, because why? Q is fixed, 4 pi epsilon naught is also constant, R is also fixed, so everything is fixed means the value will be same at every point. Let us assume this is also 1 centimeter. So if you connect all the points, right, so all the points in this circle are having a radius of, you see, all the points are having the same location, that is radius is same, right? So if this is 1 centimeter, this point is also located at 1 centimeter, this point is also located at 1 centimeter, all the points are located at the same 1 centimeter, so all are having the same potential, for example 2 volt. That's why we have, yeah, concentric spherical shells as a equipotential surface for point charge. Clear? So why it is concentric? This is for this point, it is 2 volt. If you draw in this area, the voltage will be reduced less than 2 volt. If you draw here, it will be greater than 2 volt, because closer the distance, potential will increase. Away from the distance, potential will decrease. Like that, you can draw thousands or millions of circles, so they will form a concentric, that is dense spherical circles, right? So that is very important. So two things we understood. What is equipotential surface, right? So equipotential surface for point charge is concentric spherical shell. Now we see properties of equipotential surface. What are the properties of equipotential surface? The first property is work done in equipotential surface is 0, right? So why, let us assume I have a one equipotential surface like this, right? Here let us assume this point is A, this point is B. I want to move a charge, right, from point A to point B, here to here. We know that work done is equal to Q into V. Yes, yes or no? Why? We know potential is nothing but work done per charge. W is equal to Q into V. Right here, what is the work done? Here, this point, we know in equipotential surface, all the points are at same potential. So potential at point A is, let us assume VA. Potential at point B is, let us assume VB. But VA is equal to VB. Why? Equipotential surface. That means what? All the points are having the same potential. If VA is 5 volt, VB also 5 volt. So that's why VA is equal to VB. Now I want to move a charge from point A to point B. What is the work done? W is equal to VB minus VA. That we know, right? Potential difference. Clear or not? So Q into 0. Why? VB is equal to VA. So substitute VB is equal to VA, we will get 0. So what is the work done? Work done to move a charge in equipotential surface is 0. That is very, very important. Clear? This is the first property. Second property is electric field is normal to the equipotential surface. Another important point. Normal or perpendicular, both are same. Electric field is perpendicular to the equipotential surface. Why? Okay, let us see this. Right, let us have, this is the equipotential surface. For example, we consider this is the equipotential surface. Right, so let us assume that electric field is parallel to the equipotential surface for simple, for assumption. So if you, let us assume electric field is parallel to the surface. It is like this. That means what? We are having electric field inside the surface, right? You want to move a charge from point A to point B in equipotential surface, in the surface A to B, right? This charge. We know that when you want to move a charge in equipotential surface, work done is 0. This is a property number 1. But here we are having field. When you are having field means what? We have to do some work to move the charge. Yes or no? Field is nothing but a force. So if someone is giving opposing force, I have to give a force to move the object. If I give the force means I need to do some work. But as per the property number 1, work should be 0 in equipotential surface. So electric field should not be parallel to the equipotential surface. Then where it should lie? It should be perpendicular to equipotential surface. This is very, very important point. You understand the point? So if electric field is parallel to the equipotential surface, what is the meaning? I have to do some work against the field. I have to do work against field to move a charge. Yes or no? But as per the property number 1, work is 0 in the equipotential surface. So equipotential surface must be perpendicular to the, electric field must be perpendicular to the equipotential surface. Right? This is property number 2. These two properties you must remember always. That's all about this session. If you are having any doubt, please ask me in comment section. Right? I will clarify all your doubts. Moreover, I have given some questions for you. Right? So try to solve those questions to test your understanding. Right? These questions will be eye opener for you. Try to solve this question and put the answer in comment section. If you are having doubt also about these questions, you can ask me. Right? Thank you.